Hi folks. This week we're starting into our unit of community ecology, so scaling up from population ecology, now on to communities. So just as a reminder, we define a community as all species that occur within a particular area. And the boundaries of where a community begins and stops is often unclear and is set by the observer or the person studying that community. So, for example, here we're looking at a picture of a variety of different African savanna animals. Got quite a few mammals, and then we have some birds that are easily visible in this picture. But as you can imagine, you can see plants. There are lots of microbes, fungi, protists, all within this community. And sometimes we scale communities to study them as either the bird community, maybe we're more interested in the plant community, and maybe we're more interested in the mammal community. So again, the boundaries that are set for a community are set by the observer. So community ecology in general addresses species interactions. And we call these species interactions symbiotic relationships. Or just symbioses. So before we get into content for today on competition, I want to start off just talking about some of these community level interactions or symbioses. So we're going to do this through a table where we consider species A and species B and how they're interacting together. So you see a positive sign here. This means that a species benefits from the interaction. A 0 here represents a neutral interaction. And the negative sign here represents some sort of negative interaction that it experiences in its relationship. So we're going to look at it on two scales of species A and species B. So here you're seeing in this table a list of the major types of symbiotic interactions. And we'll start off first here with predation. And with predation, what we're seeing is that one species gains a positive benefit from the interaction with species B, whereas species B suffers a negative consequence. And under this level of predation, we also need to consider herbivory, parasitism, and disease. We also have here commensalism. And with commensalism, species A gains a benefit from the interaction, whereas species B gains no benefit or negative consequence of its interaction with species A. Mutualism is when both species benefit from their interaction with each other. With amensalism, one species has a neutral interaction, whereas the other has a negative consequence of that interaction with species A. What we're going to spend most of our time talking about today is competition. So here you're seeing that both species have a negative interaction due to this relationship. And this may seem kind of weird, but ultimately there is an energy cost or a fitness cost of being part of this interaction. So even though one species may win and the other species loses, that winning still comes at some sort of cost. And then lastly, before we move on, we have neutralism here in the middle, which is a theoretical type of interaction where you're seeing both species have no net gain or negative consequence from their interaction. So ultimately, if species are interacting, we would expect some sort of positive or negative consequence of their interactions. So that's where I'm saying neutralism is more of a theoretical concept that allows us to understand all of these other types of symbiotic interactions. So like I said, today we're going to focus on competition. And again, we're seeing this negative interaction between species. And I don't know what's going on here with this, but give me a second to try to fix it here. Don't know how to get rid of this little box. Oh, there we go. So with competition, one thing that's really important to understand is that there must be a limited resource to compete for. There's no limited resource to compete for, competition isn't truly happening. So chapter 13 in your book focuses on competitive interactions. And as you look at this coral reef environment, you may be able to envision a lot of different types of competitive interactions that are occurring. Sometimes between the same species, and sometimes among different species. And we'll define those two different types of competitive interactions in a little bit today. But if you're thinking about some of the competitive interactions that may happen on this coral reef, you can think about competition for space, for food, for mates. There's a lot of different types of interactions that can be happening here. So if we zoom in on this coral reef, we may think about these two species here, which we call three-spot damselfish, and they are aggressively competing for territory. We call these agonistic interactions or aggressive interactions. And as you can imagine, they're competing for limited space in their environment. So we first need to talk about two major categories of competitive interactions, exploitative and interference competition. We define exploitative competition as that operates indirectly by the depletion of some shared limited resource. We also call it resource competition. So the key here is the indirect interaction that these species are encountering. Interference competition involves direct interactions between species, like the territorial interactions that we just saw in the three-spot damselfish. So we can break down these two major categories and think about different mechanisms of competition that fall into these categories. So our first major mechanism of competition is consumptive competition, where one species inhibits another by consuming a shared resource. So we can think about this deer here and this ladybug competing for a food resource. If the deer is a stronger competitor, then this ladybug is inhibited. And the deer becomes what we consider to be the competitive dominant. Our next mechanism of competition is what we call preemptive competition. And this happens when a physical resource, generally this is open space for settlement, is occupied by one organism and made unavailable to another. So this occurs primarily among sessile organisms. So here the example that I'm showing you in these pictures. These are gooseneck barnacles. And these gooseneck barnacles, as adults, settle from their larval stage onto substrate. And if the space is available, they're able to take over that space. So as you can imagine, gooseneck barnacles are competing for space in their environment as a mechanism of preemptive competition. The next mechanism is called overgrowth competition. And this is when one organism grows directly over another. And the example that I'm giving you here is with these two plants, where we have this tree growing over herbaceous understory plants, reducing the light available to this herbaceous understory. We can also come back and think about overgrowth competition. It's not just always with plants, and consider these gooseneck barnacles. Maybe there are little invertebrates that settle on top of these gooseneck barnacles, and they cover them completely and outcompete them for that space. The fourth major mechanism is chemical competition, and this is chemical warfare between competitors. So typically what we're going to see is that these species are going to use some sort of chemical growth inhibitor, where it's either going to inhibit the growth or even inhibit germination. And sometimes they just use toxins to directly kill another organism. So here we can think about allelopathy in plants as an example, where this plant is releasing a toxin through its roots and either directly killing the plants around it or inhibiting growth of those other plant species. And then lastly, we have territoriality. So this is an aggressive or agonistic behavioral exclusion of organisms from specific units of defended space. So back to these three-spot damselfish, where they're defending their territories within coral reefs. So all of these mechanisms can happen between species that are the same species or among different species. So we need to talk next about interspecific competition versus intraspecific competition and define these two terms. Interspecific competition is competition between individuals of two or more species, versus intraspecific competition, which is competition with members of the same species. So as we continue this discussion, some things that are important to point out is that, again, competition only occurs if there's a limiting resource, and competition ultimately reduces fitness of an individual. So the way that this happens is that obviously one individual may suffer more than another through this competitive interaction. Although one individual is going to be the competitive dominant, that comes at some sort of cost, some sort of energetic cost that can reduce fitness ultimately. So this comes back to thinking about trade-offs for energy use and brings us back to the principle of allocation of energy. And as individuals are spending more time competing, even if they're winning that competitive interaction, this comes at an energetic cost where they're not able to put as much energy into direct reproduction. So again, that's where we're getting this negative interaction as a symbiosis. So let's talk about some examples here. We've already talked a lot about these 3-spot damselfish. This is an intraspecific competitive interaction where they're competing for territories, so within the same species. Wolves are another great example where within a pack, these wolves are competing for dominance, or even among packs, where wolves are competing for territories. So coming back to our discussions on sexual selection, one thing that I want to point out is that intraspecific competition for mates drives sexual selection. So due to intraspecific competition, we see selection for specific traits in organisms or these secondary sexual characteristics that ultimately increases their fitness. So coming back to this coral reef example and thinking about interspecific competition, we may see competitive interactions for food between these two species here. We may see preemptive competition between corals of different species for places for settlement. So again, this is competitive interactions between two different species. So ultimately, competition is going to lead to two different consequences or to two different ways of that competitive interaction occurring in nature. So first is competitive exclusion. And here we have a situation where two species with identical niches cannot coexist indefinitely. And the species that uses the resource more efficiently will eliminate the other. The second major outcome of a competitive interaction is coexistence. And here the fundamental niches of two species overlap, but the realized niche does not. So ultimately, species that coexist will have different niches that they're occupying. And throughout evolutionary time, this can lead to what we call resource partitioning and character displacement, which I'll define in a little bit more detail in a minute. So if we think about the short and long-term effects of competitive interactions and how that affects niches of species, short-term effects of competition is going to potentially restrict the realized niche if they're coexisting. But the longer-term effects of coexistence are evolutionary changes in the fundamental niche of a species. So I said I wanted to define resource partitioning and character displacement in a little bit more detail. So resource partitioning can be defined as subdivision of a niche to avoid competition and direct competition. So an example that we can think about is thinking into the evolutionary past of Anolis lizards. And these are Caribbean lizards that live on Caribbean islands. And it's likely that they shared a common ancestor. And as populations started to increase over time, food may have become limited, and they then subdivided their niche to avoid competition for these food resources, becoming more specialized in the way that they're using their environment. So present day, we have this Anolis lizard here that spends its time in the canopy of this palm tree. We have this Anolis lizard that spends its time on another type of tree species in the canopy. This Anolis lizard, which spends its time on the base of the tree, or the trunk of the tree, I should say. And then this species down here that's ground dwelling, that spends the majority of its time on the ground around the base of trees. So again, if we think through evolutionary time, we can imagine that subdivision of a niche occurred to avoid direct competition, either for food resources or maybe for space or possibly another resource. So following resource partitioning over evolutionary time, what can happen are changes that occur morphologically, and we call this character displacement. So these are morphological changes that occur in a population, and it results from natural selection for reduced interspecific competition. So if we think back to Darwin's finches, for example, what we're seeing here is a common ancestor, and likely over time, we saw resource partitioning take place as competitive interactions increased. And present day, we have finches that feed very differently and also live in different niches or occupy different niches. And the morphological change that you're seeing is not only in how they look based on feather color or pattern of their bodies, but also these differences in beak shape, where now they're highly specialized to feed on very specific food resources. Another good example of character displacement we can talk about is with cichlid fishes. Cichlid fishes are native to Africa, and we find them in the African Great Lakes. And sometimes even within a single lake, we may see somewhere around 300 species of cichlid fishes that are really closely related, present day. So we see this coexistence in a single lake. And just to give you an idea what they look like, these are fishes that may look familiar to you. They're very common aquarium fishes that you can find in pet stores. And a lot of cichlid fishes are really highly specialized feeders, especially in their native environment. So we're going to look at a series of pictures of fishes that can coexist together, and we're going to look at not only resource partitioning based on their feeding strategy, but also the morphological differences in mouth shape. So here we're looking at a variety of species that all feed on algae, but have become specialists for certain types of algae. And we see very different mouth shapes that allow them to specialize on their food resources. So we're seeing a generalized algae eater here, algal filament picker, rock scraper, plant scraper, rock and leaf scraper, another rock scraper. Here we're looking at some carnivores. We have an arthropod picker, another arthropod picker, zooplankton feeder, fish eater, another fish eater here, fin biter here. You're noticing very different mouth shapes again. So smaller mouth here largemouth here, so likely this fish can feed on a larger range of food sizes than this fish here. And I also want to point out that some of these fish are in the same genus, but we're seeing, as we look at all of these different fishes, that that's not always the case. We have similarly related species across different genera. Here we're looking at a few more examples: rock scrapers, rock probing insect eater, leaf chopper, sand digging insect eater, one of my favorite mouse shapes here, and also here. Another zooplankton feeder, one that feeds strictly on the scales of other fish, another one here. We have some that even bite and eat the eyes of other fishes. Another piscivorous fish here, or fish eater. And the point here is that they likely all stemmed from a common ancestor back in evolutionary history. In order to coexist, went through resource partitioning, and ultimately, with evolutionary time, character displacement. So with that, that ends our lecture on competition.